I like to build stuff. SaaS platforms, automation tools, educational softwares, games even, a long time ago. In fact, already when I was a kid, I built the world's first fully autonomous wooden robot. Look at that. Right now, I'm teaching it how to vibe code, so even that job will be taken away from us in the near future. Anyway, today I thought it'd be fun to show you the exact tools and technologies I'm using right now. This isn't a you must use this stack kind of video, but you might get some inspiration or ideas to apply to your own projects. This video is sponsored by Akiflow. I'll talk more about them later. Now, the first question you might wonder is, how is Python involved in your system? So that's actually the first thing that I want to get out of the way, is that we're not only using Python, even though, of course, I do a lot of Python content on the channel. In fact, before I started this YouTube channel, I was using almost no Python at all, but mostly TypeScript. It was quite an obvious choice for us at that point in time. At my startup company, we were building a web-based SaaS platform. Now, of course, you could use Django or something like that, but it's really not the obvious choice. We used what most of the industry was using at that time, which is React and Node.js. Still, a lot of people use that, obviously. Personally, what I really like to use Python for is backend stuff. APIs. Automations that connect various other APIs or that handle events in various systems. And that's also how I'm using Python mainly at the moment. I'm going to show you some of the automations that I built, so you have a kind of a real-life view of how this stuff is all working. But before I dive into that, I want to show you something that's deceptively simple but very effective, and that's our static website. Now, you might have taken a look at my website already. This is what it currently looks like. In fact, we are going to publish an updated version of the website very soon. So by the time you watch this video, that version is probably already live. So it will look slightly different. What we use for our website is a technology called Astro. This is a modern static website generator that lets us write Markdown and modern components, and it compiles everything to fast, minimal HTML and JS. Because this is all statically generated, we basically host the entire website in a Git repository, and there we have all the files. So in this case, for example, for my software design course, I have this single Astro page that basically contains all the components, all the text, etc., etc. And the nice thing about Astro is that it's built on top of React, so you can basically split up everything into components, and then in the end it all compiles down into pretty minimal HTML. And then the only thing you need to do is host it somewhere. Now, I'm not going to go through the entire website with you. As you can imagine, there's plenty of different pages here, and each are set up in a similar way. The place where we host our website is on Cloudflare, using Cloudflare pages. Basically, the only thing we needed to add was then some sort of deployment system, and for that we're using GitHub Actions. And here's what the deployment script looks like. So when we push to the main branch, and then it looks specifically at certain types of files, then we're going to publish the website. And the nice thing is that there is actually all sorts of ready-to-go actions already that you can use. Like a Cloudflare specific script that allows us to publish everything to Cloudflare pages. Just need to pass the secret and the account ID, and then you deploy it. And that's basically all you need to do. So this is pretty straightforward. Why did we pick a static website builder? Because actually for most of our pages, like the homepage, the course pages, even the blog, we just don't need a dynamic backend. And by having everything static, it means just fewer moving parts, the load times are much faster and less maintenance work. And it's also a nice contrast to some of our more complex projects. Now, before I dive into the automations we've built, because that's honestly one of my favorite parts, I want to talk about a tool that helps make managing all of this way less chaotic, and that's today's sponsor, Akiflow. Akiflow is a productivity app that brings all your tasks, calendars, and tools into one single place. When you're working on multiple projects like me, juggling content, automations, courses, the websites, the actual work isn't the hard part, the context switching is. And this is what Akiflow looks like. As you can see, I have several projects here. I created one for the main things that I do. So using Akiflow is really simple. Let's create a task and then add it to my calendar. So I'm going to write a video script. One of the nice things about Akiflow is that it's smart. It uses AI, for example, to map automatically your tasks to different projects by using AI. And now what you can do very easily, because it integrates tasks in the calendar, I can simply drag this to, let's say on Thursday, I want to work on writing video scripts. So now this is being scheduled right here. It's really easy. I've also connected Microsoft Teams to Akiflow, which is the tool that we use for communication. And that means, for example, that I now have an option in Microsoft Teams to directly create an Akiflow task. For example, here there is a new landing page for me to review. And now when I go back to Akiflow and I'm going to look at my inbox, we see that now there is a new task for me that is ready to plan. So I can simply click plan and then I can plan to do that task, for example, tomorrow. There's also support for GitHub, so you can connect Akiflow with GitHub and automatically turn issues into tasks so you don't forget about them. Akiflow follows an inbox zero philosophy, but for your tasks. You can quickly capture stuff as it comes in from various tools, organize it later, and stick to what you planned for the day. This is super helpful to time block deep work, which is incredibly important for software development. You don't want to be switching between tasks all the time because you won't get anything done. If you're a developer, a data scientist, a researcher, you're juggling multiple projects, check out Akiflow, click the link in the description. Now, back to the video. I want to take a look at some of the automations we built, and I'm going to show you two of them. One is related to accounting, my favorite subject, and the other one to show the latest video on the website. I'll start with the last one. So what we did is we put most of our automations in a single Git repository. It's called Backend, not a very descriptive name, but well, it works for us. But for example, here I have my latest video automation, and very simply that's just a Python file that connects, in this case, two APIs, which is the YouTube API and the Cloudflare APIs. So basically what we wanted to do with this automation is that I have my static website, and if you go to the homepage and scroll down, well, there's my face, but what you will also see is my latest video, which at the time of recording is my video about decorators and how you probably shouldn't use them all that much. But how do you do that if this is a static website? Because we don't want to deploy a new version of the website every time I post a new video, right? So what I actually did is I get the latest video ID from YouTube. So this is an automation that we run once every week. And then I let a custom subdomain that I host on Cloudflare's DNS, and point that to the latest video. And that is what this automation does. So this runs as a Google Cloud Run function, and there's some tasks scheduling involved. So if you look at the code, this is actually really basic. I have a function to update the Cloudflare rule. So basically that's a forwarding URL, because if I go to that URL for my latest video, it's going to forward to the YouTube URL. And then I'm simply going to send the new URL to Cloudflare so that it updates this page rule, and then going to that URL points to the latest video. And the second part is, of course, that we need to get the data from YouTube. So there is a YouTube client that we use for this. So as you can see, that's part of the Google API, and that's what we use here. And what we're doing there is that we search for my latest video. So I'm providing my own channel ID, and then I get the last one. I construct the URL from that, and then I update the rule. And as you can see, there's two rules, because we have one which is like just the page of the video, which I use, for example, on my Instagram account. And there's also an embedded URL version that I'm using on my website. So this runs once a week on Friday, I think a couple of hours after the video is published or something. And then basically my website will always show the latest video. Pretty neat, right? Another example is automating accounting. So we use Stripe as payment provider for courses. So when you buy a course from us, the payment is actually handled via Stripe. And then this allows us to accept all sorts of different payment methods, credit cards, bank transfer, etc. And Stripe can also generate invoices, receipts, it computes tax, all these things that are really important if you're running a company. The only thing missing is that we need to make sure those invoices are correctly booked in our accounting system. Every business needs to do that. Now, there's lots of different types of accounting platforms. Of course, they kind of differ per country because each country has basically its own rules. I'm based in the Netherlands, so we use a platform that's called Moneybird. And this does the job for us, and they also have a REST API. So what we built is an automation written in Python that connects Stripe payments and invoices and books them correctly in our accounting software, Moneybird. And there's basically 4 different automations that we built for this. We have the consumer side, which is that if you are an individual developer, you go to my website, you buy a course, then that's basically the automation that's run. And we also have a business side, which is that if companies buy 1 or more courses for their teams, then these are the automations that are run, but they're very similar. And basically there are 2 types of automations. There's one which catches the webhooks from Stripe. So if somebody does a purchase, a webhook is being launched and then we can do something like book the invoice. Another one is that Stripe charges fees. It's a payment platform. They need to make money. They charge fees. And these are sometimes independent from individual purchases. For example, if you use invoicing or tax computations, this is like a separate amount that's written off your account every day or something like that. And we also want to, of course, capture those so that we can also book those costs in the accounting system. So what we did, let me just show you quickly the webhook for the business, is that we have, again, a main file. So this is, again, a Google Cloud Run function. And that basically handles this connection. So we have different event handlers here. For example, when an invoice is paid, then this is the code that's run when that happens. So if I go to the definition, let me show you what it looks like. So there's some type issues here. I haven't installed all the dependencies. It's not a big deal. But basically what we're doing is we retrieve the Stripe data, as you can see here. And then we get the customer information. And then what we do is we try to find if there's already a invoice in Moneybird, our accounting system. And then if it's there, we're going to update that invoice with the correct information. So that's all the things that are here. So in this case, we create a transaction, for example, and then we book the invoice to that transaction. It's a whole accounting thing. I don't want to bore you with that. I don't really like doing accounting, so I just want to automate it so I can just, forget about all of that. Now, like I said, we are using Moneybird as an accounting system, and that's basically an API. This is a RESTful API that you can use. But if you look at the code, you actually see we use a package called Moneysnake. And this is actually one thing that we were missing in our accounting system, is a proper SDK in Python. So we actually started building one of our own. This is called Moneysnake. It's an open source SDK that we're building. And this is basically a layer on top of the REST API, but it uses classes and methods with type annotation. I just want to quickly show you what it looks like. Now, what we wanted to do is make this incredibly simple. So there's basically just a few things you need to do in your code. First, of course, you need to import the package, install it and import. And then what you can do is set the admin ID and the token. So that initializes the API clients, kind of similar to how the Stripe SDK works as well. But then what you have is these classes that you can create objects of, like contacts and external sales invoices. So for example, here, this is some code that syncs contact information between Stripe and Moneybird. So we have a contact class. And then what you can do is when you have a customer from Stripe, the payment platform, you can actually use the contact class to construct a contact in the Moneybird system. So I'm supplying it a company name, address, etc. So you just make a mapping basically from the Stripe data to a Moneybird contact. And then, since you then have an object with methods, you can do things like setting a custom field, such as the Stripe customer ID, so we can find back the customer in Stripe if we have the customer in Moneybird. And you can also simply call save, and that's going to update the customer in Moneybird by calling the API with the correct methods and arguments. So in short, an SDK like this really makes your life a lot easier. And again, Moneysnake is an open source package. If you happen to be based in the Netherlands and you're using Moneybird for accounting, feel free to use this or to contribute to the project. Now, there's one more thing that I want to show you, but if you're enjoying this video so far, give it a like and subscribe to the channel if you want to watch more of my content. This is a small thing, but it really helps me a lot. Now, one of the most impactful things we built this year is the ArjanCodes business portal. And that's really how we manage access for companies and teams that buy our courses in bulk. So the automation that I showed you before for mapping Stripe invoices to Moneybird invoices, the accounting system, that's basically connected to our business portal. And the key feature of this is course licenses for teams at businesses. So a company can purchase multiple licenses for a course, and then they can invite team members to join. And this is basically what that business portal looks like. Our business portal runs on Google Cloud as a Cloud Run instance. So this basically means, hey, Google, here's a Docker image. Please run the Docker image and give me a URL. That's basically what it is. Now, in this business portal, like I said, companies can buy multiple licenses for a course. They can invite team members to join. And then the portal takes care of granting course access and billing and basically having a dashboard where you can manage all that stuff. And on top of that, we created a public API so that companies can integrate all these things into their own systems. And this is what the documentation looks like. So this is being generated from the actual API. Now, for the business portal backend, we actually recently moved to Next.js, which has a built-in API. So as part of the source code of the portal, we have an API folder with routers where we have the various things in our API. So for example, we have a course router where you can get course information. And so that's all part of the same system. So I'm not even using Python for this anymore. What's nice about using the built-in API from Next.js is that this is very lightweight, it's really easy to develop with, and we don't have to switch between Python and TypeScript for this particular portal. Because the app, which is basically the whole front-end application, is built with TypeScript and React. So we have all these different pages that contain basically all the implementation of the whole front-end dashboard. Now, this portal also relies on a database because obviously we have to store information like how many licenses a company bought or who those licenses for courses are assigned to. And for that, we're using MongoDB. And the reason I'm using MongoDB is that it gives us a lot of flexibility as the data model evolves. So there's no rigid schemas. We can roll out new features without having to do many migrations. Now, of course, MongoDB has its issues. I mean, the lack of structure means that things can get inconsistent. And if you do need to migrate to a different structure, that might actually be harder. And on top of that, if you need strong, consistent relationships between documents, MongoDB might actually not be the best choice for you. But for us, it actually works quite well. I think in particular, when you're dealing with a system that's changing a lot, and that's often the case in a new thing that you're developing, having a flexible database is actually quite nice. Now again, nothing against SQL-based databases. I've also used those quite a lot, but for this project, we opted to go with MongoDB. Now, just like all the other things we're building, the portal is also deployed with GitHub Actions. So as you can see, I have a YAML file here with the release. So basically, whenever we publish a release, then we're going to also deploy a new version of the portal. And that means deploying a new Docker image. So we have to create the artifact. We have to set some environment things like the image name and stuff like that. And we actually build the artifact with Docker. And then we push it and deploy it to Cloud Run. And then finally, some cleanup. And that's basically all there is to it. So this is pretty simple, actually. So as you can see, the stuff we built is actually pretty straightforward. So for automations, it's just simple Python scripts that run on Google Cloud Functions with a bit of scheduling in the cloud. For the website, we use static website hosting. We can just edit some markdown files and we can update the website. For our business portal for companies, we use a single front-end built in TypeScript and Next.js, which is also pretty straightforward. So for us, working with these different tools works actually pretty well. We're a pretty small team, and for us, speed matters. We need to keep things simple. So Python is the most simple solution, I feel, for automations and for some backends. TypeScript is really nice for front-end stuff, especially for interactive things like the business portal dashboard. We use serverless things like Cloud Run and Cloud Run functions because that just reduces our operational overhead. It's much simpler to manage. We use GitHub Actions for all the deployments. And using this stack, it lets us move pretty fast. We can automate the boring stuff and we can focus on doing things that matter most to us. Now, I'm curious, what do you think? Are these the same technologies that you're currently using in your own stack? Is Python your go-to, or are you using something else entirely? Let me know in the comments. I'm curious to learn what you are building your apps with. Now, I haven't talked much about how we use Git. If you want to learn more about branching strategies and how to use merges, fast forward, and rebasing, check out this video next. Thanks for watching and see you next week.